Welcome to this talk that will be about the security. The title is sort of catchy, but generally what we will talk about is the security and the security on a daily basis from the software development point of view. It will be about, let's say, hidden weaknesses in your code, how to find them and how to, let's say, defend against them. First of all, I would like to introduce myself. My name is Lukas, I'm from Slovakia. I like hiking, so this is actually the photo from Vatakamen where I did some small hike on Saturday because I came here a little bit in advance. I am a software engineer for around 10 years now. I work mostly in life science companies, meaning they deal with software from the area of biology, chemistry, health, and so on. And currently I work in Thermo Fisher Scientific, which is a worldwide company dealing with chemistry, mostly with chemistry and biology. I also want to emphasize that I am not a security expert, so this talk I will really do from the development point of view, and let's say from the my daily business is writing code, so from this point of view I will also do this talk. And I like to start it with this quote that I have seen a few years ago at some conference, and I can really relate to that one because from these 10 years of experience that I have, I really feel that people don't care that much about the security. I mean the software developers, right? If we have some meetings within Scrum like about tech quality and so on, I have found out that we don't talk that much about the security. And the quote says that security is like spinach. One knows it's very beneficial, but doesn't really eat it that much. And I really relate to that one because we know that security is important. We know that our applications should be secure, but still we don't really care, at least from my perspective. And then like once a year there is some penetration testing done by some external company, or we run CodeQL or whatever, and we find a lot of vulnerabilities, and suddenly the management is really like eager to solve everything, and suddenly the security becomes a top priority. But I would like to show you that security should be like a top priority or one of the top priorities all the time. And so one of the statistics says that 86% of developers don't see security as top priority, which is actually kind of big number, but what is maybe even worse, it's that 1/3 or 33% don't even know what makes their code vulnerable. And the goal of this talk will be to start your journey out of the previous statistics. So if you don't know what makes your code vulnerable and so on, I will try to give you some hints and show you how you can improve it. And I will try to show you the details that can have a huge impact. And also I would like to show you that it's just not about the firewall and the open ports. And the last but not least, that we as developers, we can do a lot to improve the security of our application. But first of all, why you should care? So there are a few reasons. First is of course reputation. You might have very good product that has a lot of users, it's really successful, but suddenly there is some data breach, like the passwords are leaked or whatever, so the reputation of your company is sort of screwed, or reputation of the product. Then it's efficiency, because proactive approach is much cheaper than the reactive. So if you start dealing with security since the beginning of your application, it's much cheaper, right? Then after 1 year maybe, if you don't care, after 1 year you run this CodeQL tool or whatever, and you find a lot of vulnerabilities, then it's much more expensive to, let's say, get rid of them. So efficiency is very important, and also the value, because if you know at least something about security and about the vulnerabilities, it definitely makes you more valuable on the market. So you have the skill, and market really appreciate that one. What are the consequences of security negligence? Of course, there might be some data breach, so passwords are leaked or other sensitive information, denial of service attacks. So for example, your website becomes unavailable, maybe right before the presidential election or whatever, and the users might be sort of not satisfied with it, or it might not be good for your reputation. And then of course unauthorized access, so the malicious user can do forbidden things with your application. And then it's business logic abuse. The first time when I gave this talk in May, just a few days before the talk, I found out that there is one application that I was using on a daily basis, and I have found out that they have limited amount of operations that you can do during the day, like it's 3 or 4, and if you, just in case you pay for the license, then you can do the unlimited amount of those operations. But with free account, let's say you can do only 3. But I have found out that if you are offline, it's not checked. So if you are offline, you can do as many operations as you would like. So it's really like a business logic abuse, because this company then is losing the income, or the product that I was using is sort of using income because people are not forced to buy the license. They can sort of bypass it and use it offline, and it's actually it's not Tinder, it's other application. I don't want to name it. So from my point of view, or from my opinion, in my opinion, the reasons of negligence are mostly those three. First is misconception, because a lot of developers, they think that DevSecOps will solve everything, so they just develop the code, and then some people will configure everything. Yeah. Other misconception is we turn on the firewall and we disable all ports but 80. So they again think they just develop the application and some security guy will disable everything, but this port will stay open and then the application is secure. Of course, other one is we are too small to become a target, so the company might think that their business is not that interesting and that they don't need to have the app secure because nobody will sort of attack it. Then it's knowledge. As I said already, 33% of people don't even know what are the vulnerabilities, and they don't know what are the good patterns in API development and what are the anti-patterns, for example, patterns for authentication, authorization. And then the third reason is the management, because I have the feeling that management doesn't support that much the development teams. They don't provide the money for tooling, they don't provide the time, let's say. So management is also the reason, so you can blame them. Then if you think about it, about when you have some API and you have some client, it might be a browser or it might be some other client, it's not always the browser, but generally it's very long path from the actual request, let's say in Google Chrome, until it gets to the server and then back. So it's not just one hop, like you make a request and then it comes to the server. It's a lot of places between. So it's like a browser, then it's like some network elements like routers, network configuration. Then it's of course the server, like a hosting machine, and then it's your code. So all of those places are naturally vulnerable. I mean the browsers, because in browsers you have cookies, you have headers, and it depends on the browser, how the browser, for example, how it deals with cookies, because there are some settings on cookies, like for example, HTTP only or same site attribute. So it depends on the browser how it deals with cookies. So for example, if you have the HTTP only cookie, the browser should not allow you to access it from JavaScript. But if there is a bug in the browser, well, then the JavaScript can access it, and it's a bad thing. So then it's a network, hosting machine, as I said. And then, most importantly, is the application code itself. So it's either third-party code that you are also responsible for, so like some nuggets, libraries. In C# it's nuggets, in Java it's libraries, also in Python, so it depends on how you call it. And then it's of course your code. That's why I put there this picture of the Trojan horse, because it might happen that there is some attacking request, and it gets through all of those elements. So it gets through the browser, let's say, it gets through the network, and also it gets through the hosting machine and through the server, so for example Kestrel or whatever, and suddenly it's in your application code. And then it really happens what happens in your application code. Then it really matters like what's happening in your application code, whether you somehow find out that it's a Trojan horse or you don't find it out and your app is attacked. So how to find out what makes your code vulnerable if you don't have any experience and so on? One of the good websites or one of the good resources is this CWE. It's Common Weaknesses Enumeration. And what they do, they release every 1 year or basically regularly, they release the top 25 list of some top 25 security vulnerabilities. It's like a little bit low level from my point of view, so that they really go on the level like, for example, you have in C, for example, you deallocate the memory and then you access it, so they go sort of low level. And then there is other good resource or good community. It's called OWASP. It stands for Open Web Application Security Portal, and it's online community, and they provide free resources about the software security. And again, periodically, like every 2 years or every 3 years, they release the top 10 list of top 10 security vulnerabilities. This is the one from 2023, I guess. I just put it there so that you have sort of an idea how it looks like. And every item has a description. It means that they tell you what is behind the security vulnerability, or they explain it to you. Then they tell you how to prevent it. And there is also some example of attacks. So for example, one of the most common one that you can have on a daily basis in your code as a software developer in your API is the mass assignment. It was in 2021, it was on the 3rd place, I guess. So I'm just putting it here randomly, so it's not, maybe in 2023 you don't find it because it's hidden in some other item from those 10. But basically mass assignment is about the attack that attacker enhances the request. So let's say you have some JSON object or JSON request that you send to the API with a few properties, like for example the name and the surname of the user, which you would like to update. So you come to some website like Facebook or something and you would like to update your name and surname. So the JSON is sent to the API, but then the attacker finds out that they can also set some other property. They can send to this JSON, they can put there, like for example, is admin equal to true, right? And that's not a problem until the server doesn't process the enhancement. And the example of this attack was 10 years ago, or example of a famous attack was few years ago when it happened to GitHub actually, that the user was able to put their public key, and they could put whatever repository in the request. So they could put this public key to arbitrary repository and then have read and write access to it. And I'm not sure you can see it well, but this is the example of how the code can look like, the vulnerable code. So let's say you have the update method on your controller. It's accessible with the HTTP patch method on the endpoint update / the ID of the user. And then you can put there is the ID and then the JSON object, which is deserialized from the body. And the problem of this code is that it goes through all of the properties that are in the user class. You see it on the 3rd line of the method, that it iterates through all of the properties of the user, and it tries to find this property in the JSON object. So basically, on the UI, you intended to use this endpoint to just send there the name and surname, but on the user, there is also property like password, for example, or the property is admin. And the malicious user or the attacker can find it out, so that they also put this to the JSON. And then this code, it iterates through those properties of the user, and this code finds the property is admin there in the JSON object, and it really assigns it to the user class here. Okay, you don't. Here on the last line. Here it's assigned, and here it's saved to the repository. And if you actually think about this code, it might look a little bit strange, but it's basically very similar to how automappers work, right? Because they try, based on the reflection, they try to find the property in the first object and assign it to the second one. So if you are, let's say, using automappers, then it might be a problem that suddenly the attacker might be able to assign the property which you didn't intend to be assigned. Then it's unrestricted resource consumption. Again, one of the top 10 items from previous years. Basically, example of this is the denial of service attack. So it means that you don't really restrict on how many times the user can access some resource. So for example, you don't restrict it to 1 access per second or 1 access per 10 milliseconds or whatever. And I have here a small example how you can configure it in .NET Core API, for example. So we configure the IP rate limiting options, and it means that basically whatever endpoint will be accessible only 1 time per second from whatever IP address. So generally, even if you didn't access it before and somebody else accessed it in the last 1 second, you cannot access it. And here is the response that you get if you access it like more than once per second. So it's like 429, and you get the error response that API calls quota exceeded, maximum admitted is 1 per 1 second. And it's good because you configure it obviously really good in a pure REST API, but then what might come into action is the GraphQL. And in GraphQL, in one request, you can put there like more sub-requests, right? So generally, the author of this API would just assume that there would be just the first one or just one request right at the beginning, lines 2 until 6, but you can put basically arbitrary amount of requests or sub-requests to one GraphQL request. So this will really pretend to be just one request from the API point of view. And here are the data returned. I can see the. Yeah, so here the data are returned, and here you can see these are the server-side logs that the method was really executed 4 times. And that's basically a problem of GraphQL, which is sort of getting really popular last years. People start using it and so on, and they might not know about all the vulnerabilities that it brings. So that's why I point out this another website or another resource is again on this OWASP, but this time is not top 10. This time is OWASP cheat sheet, and you have there a lot of good resources to every technology that exists, not every, but to all of the popular ones. So there is big section dedicated to GraphQL, and you also can find there all these informations about what security problems are there in GraphQL and about these batch queries in GraphQL and how to limit them. So that's also another good resource, this cheat sheet. Then it's injection. I guess everybody knows about SQL injection. It's probably the most common security vulnerability. It's often people ask it on the interview. When you come to the interview, they ask you whether you know what that means. But also other type of injection is the XSS, cross-site scripting. And it basically means that you are able to inject some JavaScript into some database column or whatever, and this JavaScript is later on executed on the client side, on the trusted website actually. So let's have the example of this. So let's say I have here this database. Just the users are there, so the name, surname, and some other properties, but they are not important for this moment. And in name, I have a real value, like Lukas, Jane, John, Peter. And in surname, I have some, basically, either the correct value, like McAllister, or some JavaScripts, right? And it's really interesting because it depends on, it doesn't mean that if you have this JavaScript in your surname, it doesn't automatically mean that your code is vulnerable, because it really depends on many things, as we will see right now. So for example, here I have the image, basically the tag for image, but then I have there this onError function, which is executed when this source is not available, and I have there X, so it basically it will always execute this onError function. And here I have the real script tag with some JavaScript inside. And now let's have a look at the web application, like the code first. So this is the Node.js that I am using, and this is the Node.js engine used to build dynamic websites. So here I have the users loaded on the backend sign section, and here I have, you see the table, headers, and here the body. And here I iterate through every user, which I get here. It's just the JavaScript and the SQL call executed here. So it's so far so good. And here I do it with this Node.js engine. And here I just put there this tBody tag, and I put there this ID user table body, and I intend to load it with JavaScript once the DOM is loaded, right? So I load it with JavaScript, and you will see the difference as soon as I open the website, right? It's here. So you can see that here, that's the one loaded with the Node.js engine. Here it's really escaped, right? You can see here the values that I have in the database. I will put it a little bit bigger. So in the first case, it's not executed, right? So it's, in spite of being in the SQL, it's not a vulnerability, it's not a problem, because this Node.js engine escapes the stuff when it puts it to the HTML. So it's good, but this JavaScript, it doesn't actually do that, this code. And you can see here that it's not escaped, right? And when you come to the console, you see that some functions were really executed. And this XSS on error function, so it means that this was executed. This was actually not executed, right? Because it's sort of, the browser protects it. So browser sees that there is some injection of the JavaScript where it should not be. But so the browser finds out and it's not executed, this one. But this is executed because the browser thinks that it's an image and it executes this function. And when it's really interesting, it's that when the attacker sort of abused this, because here, what I have, I do the fetch, the GET request to this website, and it's the different one. It's basically, it's this malicious user API here on this port, right? And when the website is loaded, this one, you can see that this code gets all the cookies here, the document.cookie, and it sends them to this website, to the malicious user basically. And when we press F5 a few times, you will see it here, right? So this way, for example, the attacker can put there this sort of JavaScript, and they can get your cookies, and those cookies are sent to the endpoint that they specified. Here could be like not the local host, but here could be like maliciouswebsite.com, right? And it's, again, one of the interesting things is the behavior of the cookies. That's what I said about the browser. Because here, when the website is requested, I put there the two cookies. One of them under the key HTTP only, and another one under the key not HTTP only. And they differ by this setting, right? And as you can see here, they are both here. So the HTML is able to access them. So they are here, but here I use the document.cookie, and here only the non-HTTP only is sent, right? So this is again something that on a daily basis, basically when you are adding some cookies to the request, here I specified it, right? Here I specified whether it should be HTTP only or not, but generally it's not required, right? So you can sort of not put it there, and then it depends on the framework. For example, .NET Core automatically sets it as HTTP only to true if you don't set it, but it really depends on the framework that you are using. For example, you might be using some Python stuff or whatever, and then it might be the default might be false, right? And so this is about the cookies. And you need to sort of, the browser needs to cooperate with you, because if the browser doesn't care about this property, then it would send all the cookies, let's say. Okay, and one thing is that you write a code that is, let's say, not vulnerable, but it's not that possible, or it's not 100% possible, because you are not the only one in the company, let's say, and it might be a lot of code coming every day. So one option is, of course, to write 100% safe code, but other option is to use a good tooling, right? And this is one of the memes that I downloaded from the internet. When you write the security memes, this is one of the first ones. And I can again relate to this one, because the budget for the security might be very low, like before some breach, but then when there is a breach, or when there comes some external company doing the penetration testing, they find a lot of stuff, suddenly the management is really willing to put a lot of money there. And what are the good tools? So it depends on whether you would like to do the static code analysis or you would like to do the runtime analysis. For example, for static code analysis, it might be CodeQL, SonarQube, and actually even GitHub Copilot. I decided to put it there because, yeah, I'm using it kind of often, like last year, and it might tell you about some things we will see later on. So even if you don't have the CodeQL or SonarQube incorporated, you can still use GitHub Copilot. I know that a lot of companies are now buying the licenses and developers can use it, so even GitHub Copilot might tell you something. And then there is a runtime analysis, so for example, Fuzz API or Zap, and even the DevTools, which is actually, wait, okay, now probably some problem with the slides, not correct order. Yeah, but this is, for example, the Zap tool that I tried to run on my website, and you can see that it tells me that I do have there some cookies which have no HTTP only flag, right? And there you can see HTTP, non-HTTP only. And here it exactly tells you the tool, a cookie has been set without the HTTP only flag, which means that the cookie can be accessed by JavaScript. If a malicious script can be run on this page, then the cookie will be accessible and can be transmitted to another site. If this is a session cookie, then session hijacking may be possible, right? So this is exactly the thing that I showed you before, that this cookie that was not set as HTTP only was accessible, right? And the attacker could get it from you if they are able to execute some script within your browser and on some trusted website. And the tool writes you the solution that you must make sure that the HTTP only flag is set for all cookies. Then there is some tool that is natural and it's free, and it's the developer tools in every modern web browser. And you can basically inspect there all the requests and responses. You can inspect the cookies, and you can see the consoles. Also, this way you can find out like what's actually going on between your website and API, for example. And this is the, let's say, the website that just shows the users. And what you can do in the DevTools is that you can go to the network part and you can inspect like what's going on. And for example, there is this GraphQL request, which I use to get the users, and you can see the payload, right? You can see that there is a query, and I would like to get the name, surname, and profile picture. And what I can do with this request, I can copy it, for example, as a PowerShell script. So you right-click on it, then you click the copy, and then you select the option. So for example, I selected PowerShell, and here I have the PowerShell script that I can actually execute, and I can try to modify it. So for example, I did a small modification there, so I'm trying to also ask for the password, right? You will maybe not do this with your website, or you can also try it with your website, but you can come to whatever website on the internet and you can try to play with the requests. And this way maybe you find some vulnerability. For example, you can on Facebook, you check who liked some post, and there should be just the profile picture of the person and the name and surname. But maybe you will find out that you can play with the request a little bit and you ask for a password or something. And yeah, I modified it and then I executed it. This is on my website, right? It's not Facebook. And then I was able also to get the password. And this basically leads to another vulnerability, which is called oversharing. And it basically means that you are sharing more than the client or the UI or whoever requires, right? Because in this case, the UI requires just the name and surname and maybe profile picture, but you are also sharing the password. And it's again the problem with GraphQL, because usually, I guess all of you or majority of you have seen this attribute, JSON ignore, and basically when you use JSON ignore, the property is not sent to the JSON via the classic REST call, right? But it doesn't apply for GraphQL. They have other attribute to be used. It's called GraphQL ignore or something like that. And developers might very often, they see there is JSON ignore, so they think, okay, this is ignored in every technology, and basically then they start using GraphQL and they have the vulnerability because GraphQL doesn't take this attribute into account. So that's oversharing, that more is shared than necessary actually. And here I have, because usually I do this talk for 30 minutes, but this one is 40, so it's actually also nice time for a bonus block. And it's also very important to talk about the GitHub Copilot and its impact on security, because as I said, Copilot, it's getting very popular last months, let's say. And actually, this code that you saw before, it was generated using GitHub Copilot. So there might be a problem that how Copilot actually works, because Copilot was trained on public repositories from GitHub. There is a lot of those repositories, and as you might guess, they contain also security vulnerabilities, right? Because it's not possible to train it only on the repositories that are 100% safe actually, even because it doesn't exist 100% safe repository, like in every code there are some vulnerabilities. So it was trained on those data, also on the, let's say, insecure data, and that's why it might also provide you the code that is actually not secure. So as I said, this was provided by GitHub Copilot. I was doing this before there was this magic tooltip that I will show you. But you can actually ask it what it thinks about the code, right? So here, I'm asking it, can the code in fetch users via REST method in index PUG lead to some security vulnerability? And it's able to tell you that yes, the code in the fetch user via REST method can potentially lead to a security vulnerability, specifically cross-site scripting. This vulnerability arises because the method directly inserts user data into the DOM without sanitizing it. And it also, here is the explanation, and there it also provides you the mitigation. To mitigate this risk, you should sanitize the user input before inserting it into the DOM. One way to do this is to use text nodes instead of inner HTML. And then also one very good thing that they incorporated into the Copilot chat, if you have it. If you use the chat, then you maybe noticed this emoji with the tooltip. So when they generate, you don't see the, when the GitHub Copilot generates code for you, it might put there this emoji of the shield with the tooltip, and it might tell you that, for example, there is some potential vulnerability, and it tells you that there are hard-coded credentials. Embedding credentials in source code risks unauthorized access. This is different method. I had this screenshot there from other presentations, so I decided to put it there. It's not the one that we saw before this fetch. But still, if you see there this shield, you should definitely click it and see what might be the problem. Because, yeah, as I said, usage of Copilot comes with the security risks. I'm not saying that it's insecure, of course, it really depends, but it's good to know that it might be insecure what it generates, but good to know that there is this emoji and you can see the problems. And one thing I wanted to show you is that when you really use the method that it suggested to you, it takes some time because it's 3 different applications. Okay. This is the improved method that it suggested. Right, and now you can see that also this second loading, which was causing problems before, it's fine, and there should be nothing in the console, right? So nothing was executed, and also if I refresh it a few times, there is nothing here in this API. So the malicious user or the attacker is not getting your cookies anymore. So this is the way that Copilot can generate insecure code, but it can also tell you that it's insecure, and it can tell you it can give you much better version. And we have just a few minutes left. So it's the time for some short summary. So there are a few musts, because your app will be never like 100% secure, it will be never like 0% secure, but it's really hard to get the security right, you need a lot of knowledge, and it's like you go step by step, you learn day by day. But the few musts that are there, it's AAA, authentication, authorization, and accounting. And it's not just about setting it somehow. For example, in .NET Core, it's really about understanding the best practices and patterns. So for example, you have this backend for front-end, pattern, and so on. So you should understand all of them. Then it's like input checking, sanitization, definitely always check the input. For example, when the JSON comes, try to whitelist the properties and remove all of the ones that are not in the whitelist, or remove the ones that are in a blacklist, and sanitize it so that it cannot be treated as HTML. Then it's rate limiting, so definitely limit your resources, for example with this IP rate limiting options or something else. Then secrets, you should definitely avoid hard coding them, because if you have some If you have API, then it's probably not that easy to, let's say, to use disassemble for it, but if you have some application that is installed on at the customer, for example, they can use some disassembler and they can see the code. So you should not hard code the secrets, and you should rotate them. For example, on Microsoft Azure, you have those services that have endpoints, a lot of them, and you can just click one button and it changes the key or some secret. And then it's code or application analysis that you should do regularly with some toolings. Yeah. And then there is an image to demonstrate that security is not really black or white. It's like somewhere in the middle. It's like a spectrum because it's the constant evolution of your code and also of the context of your code. You might have some code that, let's say, doesn't cause some security vulnerability. For example, the one that we saw at the beginning, the JavaScript, the setting of the properties from user to from JSON object to user. Sometimes it might not be vulnerable because you might have it somewhere in some low-level library of your code, not directly at the controller, but then somebody, your colleague, decides to take this code and use it in some other context. So it's like context of your code changes all the time. So also the security goes from secure to insecure and then back and so on. And then you update the third-party libraries. For example, you are using Log4j or some other logging frameworks. There was a big bug in Log4j a few months or a few years ago, like 1 or 2 years ago. So it's changing. You are updating those libraries. And then the browser updates. It depends how the browser behaves, as we saw with these cookies, for example. And of course, there are new ways of attacks all the time. And there is a quote by Gene Spafford, security expert, that the only truly secure system is one that is powered off, cast in a block of concrete and sealed in a lead-lined room with armed guards. And even then, I have my doubts. So the secure system doesn't actually exist, but you can definitely make some good work to make it more secure. And that's it. So I would like to thank all of you. This is the QR code for my LinkedIn website if you would like to follow me. Sometimes I write there about the GitHub and about the security and so on. So thanks a lot again and enjoy the rest of the conference.